Second half of 9.7, we're going to be looking at the error, or how far off we are with these polynomials, the Maclaurin and Taylor polynomials. We're going to start with the third Maclaurin polynomial for sine of x. So take a moment, pause the video, and write out what that would be. You should have ended up with the third Maclaurin polynomial, that is centered at 0, would be x minus x cubed over 3 factorial. The error of this polynomial should make sense that the absolute value of that error will be the difference between the actual function value and our polynomial's value, the absolute value of that. Taylor's theorem says that if f is differentiable through order n plus 1 on an interval that contains c, the value that we're centered at, then for each x in that interval, there exists a z value between x, the value that we're evaluating at, and c, the value that we're centered at, such that the function is equal to our polynomial plus the nth remainder. And that nth remainder is found by the n plus 1 term where that derivative, the n plus 1 derivative, is evaluated at some z value. And we want to look at the worst case scenario for this, and that's when that n plus first derivative is at its maximum value on the interval x to c. That's what this numerator is going to be looking at. So we're going to use this theorem to approximate the sine of point 1 using our third polynomial, our third Maclaurin polynomial, and we're going to determine how accurate we really are. So the sine of x is equal to that polynomial we came up with plus the third remainder. So it's x minus x cubed over 3 factorial plus the fourth derivative of our function evaluated at some z value, where z is between 0 and 0.1, over 4 factorial times x to the fourth. So using this, we find that the sine of point 1 is approximately 0.1 minus 0.1 cubed over 3 factorial, which is approximately 0.099833. The fourth derivative of sine x evaluated at z is equal to the sine of z. So if we're going to figure out what bounds our third remainder at point 1, we need to think about what this is going to be. The simplest is that the remainder has to be bigger than 0. But worst case scenario now, we need to look at that sine of z over 4 factorial times 0.1 to the fourth. That was our remainder term. We need to figure out what's the worst case scenario for that. Well, the worst case scenario would be at the maximum of sine z on the interval 0 to 0.1, and we can actually do one better, saying that sine of z, the worst case that can be, worst that can be is a 1. So our remainder needs to be less than or equal to 0.0001 over 4 factorial. And we're getting that by doing 0.4 to the fourth, 0.1 to the fourth over 4 factorial. So that means our remainder needs to be less than or equal to 0.000004 and greater than 0. So sine of 0.1 based on Taylor's theorem will need to be between 0.099833, the value that we got from our third polynomial, and that plus our 0.000004. So this is telling us that our approximation is pretty good. The assignment that goes along with this is from 9-7 again. And adding on to the problems from the previous section, I want you to look at 45 through 47. So just 3 problems, but they're all involving this area calculation.